So in this section, we are going to look at some common faults that are associated with steam turbine during operations and common remedies, things that you can do to actually take care of these problems as they happen within the steam turbine during operations. Okay, so in the course of this, we are going to look at faults that are associated with blades, issues with blades, okay, and how we can guide against such issues, okay, so that they do not disrupt the operations of our steam turbine and thus the operations of our process. There are rotor problems, problems that are associated with rotors like this. Okay, we are going to look at them and what we need to do to guide against the occurrence of such problems. Then bearing issues, bearing problems. Of course, we know that in the course of usage, the bearing will definitely wear. There are some operational conditions that enhances the wear and tear of these bearings. Okay, so we are going to look at some of these issues and what we need to do to prevent such from occurring and thus extending the life of our bearing and thus also of our steam turbine. Then seal, mechanical seal failure. Remember earlier in the section we discussed the function of the seal. Okay, so once here we have the seal, that is what we have here, okay, and here. So the function of the seal is actually to contain the steam within the steam turbine. So if there is any leakage, either at the back or front, wherever, you will see that that can cause loss of efficiency of the steam turbine. And if there is leakage around this area, it can cause the destruction of these bearings also. Okay, that will further accelerate the breakdown or shutdown of your steam turbine. So we are going to look at seal failures, the possible causes and the possible remedies. Then the governors we have also identified in our previous section helps to regulate or control the speed of the steam turbine. That is what we have here. Okay, so that unit, there are some problems also that could be associated with its operations that can affect the operations of the steam turbine. So what are these fault conditions? What could possibly cause these fault conditions? And what can we possibly do to remedy such situation? We are going to look at them. Then for condensing turbines, the condensers, being that it is a heat exchanger, as we said earlier, you see that all the problems associated with heat exchangers, okay, could also be experienced by the condensers. So once we have problems with the condensers, it means that the efficiency, because the rate of condensation will be affected, and then the vacuum level at the condenser, or rather at the exhaust system or section of your steam turbine, will be affected, and that will eventually affect the efficiency of your steam turbine. So this is the condenser, okay, so that is what we have here. So like we said, is an heat exchanger. All the problems associated with heat exchangers are also experienced in the condensers. Okay, so we are going to look at all of those later and what we need to do to actually prevent such from escalating or disturbing the operations of our steam turbine. Then other issues associated with the steam turbine, we are going to discuss them. Some that may be associated with other auxiliaries, okay, of the steam turbine, the cooling water system or the cooling system, the lube oil system. Okay, so we are also going to look at all of those So without wasting much of our time, let's look at blade issues. So we all know the function of the blade. We know that the blade is what is responsible for the main function of the steam turbine, that is to convert the kinetic energy that is contained in the steam into rotating mechanical energy. It is the blade that receives the steam, okay, that receives that kinetic energy. Okay, so that energy acting on it will cause it to move, as we discussed earlier. Okay, so these are the blade. As the steam impinges on them, it causes the rotor to rotate. So it does the conversion of that kinetic energy into rotating mechanical energy. So anything that affects it affect the efficiency of the steam turbine. So the first that we are going to be looking at is erosion. Erosion of the turbine blade. That is the steady wear, okay, removal of the surface material of the turbine blade. Okay, so that will invariably cause thinning, as you see. Are we getting it? And that thinning will reduce the strength of the blade, and that will result to other problems on the blade, and will also affect the efficiency of the blade also. So erosion, what can actually cause erosion? Erosion, they are caused by maybe if you have condensates, okay, that is droplets of water in the steam, that is the steam is not dry enough. So since it is coming with that high velocity, okay, on impinging on the surface of the blade, it has the capability of eroding the blade surfaces. Are we getting it? Then also too, if your steam is not pure, we have some debris in them that can cause erosions like this. Or if we have precipitate, that is insoluble salts, okay, or rather soluble salts, okay, precipitating out of the steam, that is the water that is sent into your boiler is not properly demineralized. Okay, so such precipitate within the steam turbine, are we getting it, can cause this kind of erosion because of the speed with which they are coming to impinge, okay, or strike on the turbine blade. Okay, so that is the cause of common causes of erosion on the blade. Then we also have corrosion, okay, on the blade. Remember, when all the elements that can cause corrosion are available, are we getting it? Say water, then oxygen, okay? So you see that that can cause corrosion of the blade, and once the blade is corroded, that can affect the integrity of the blade because it will not have that design strength, okay, to withstand the operational conditions of the steam turbine, and that can result to all other conditions. Okay, so when your steam is not of the right specification, remember, in water treatment, you need to remove the water that you send to your boiler. Okay, you need to remove oxygen from the water. Are we getting it? So those oxygen, if they are not properly removed, and we then have some droplets of water, okay, especially towards the the low pressure side of the steam turbine. Okay, we know that on the low pressure side the steam is cooler. Okay, and since it's cooler, the possibility of us having condensate around that area is high too. Okay, so that can enhance the corrosion around that area. Okay, so the as we'll see later, effective boiler water treatment is what is needed to avoid this kind of problem. Of course, once the stress is repeated like that, okay, remember, erosion and corrosion reduces the integrity of the blade, and with repeated stress because of the operating environment, the harsh operating condition, okay, around the blade, that can cause fatigue stress that will eventually result to something like this. Okay, breakage of the blade that can also cause problem, okay, downstream or around the turbine casing. Remember, the blade is turning, so there are centrifugal forces acting on each and every blade that you are seeing here. So when any of them breaks, that centrifugal force will drive it out towards the casing. Okay, so on striking the casing, it can result to other problem. So erosion corrosion can result to this cracking when the blade is subjected to more stress, as you are seeing here also. Okay, so that cracking reduces the integrity of the blade, and if the blade break as we discussed earlier, okay, that can result to rupture of the casing. And once the casing is ruptured, all the steam will be escaping from that area, and thus the efficiency of the steam turbine will be affected. Okay, so what are the remedies? One, erosion. We already know what erosion is: the steady wearing away of the surfaces of the blade material. Okay, so when we use the appropriate blade, or the blade that is made with the appropriate material that will be able to withstand the operating conditions that the steam turbine will be subjected to, okay, that will help us a great deal to remedy this effect of erosion on the blade. Then we also need to improve the steam quality, like we said earlier. So first you have to demineralize, which means that that is your boiler water system. Okay, you have to demineralize the water, which means that your demineralization unit or water treatment unit must be effective. Are we getting it? So all those soluble salts, remember, all the insoluble salts will be filtered out. That one will be easier to be removed, easier for the system to be removed. Then the soluble salt, which is the problem, your the main plant have to be effective enough to remove all the soluble salts within the system, that or else those soluble salts will go and precipitate out of solution, okay, or even get deposited on the turbine blades, and thereby reducing the efficiency, causing unbalance or vibration within the unnecessary vibration within the turbine. Okay, so all the soluble salts will be removed. Then the dissolved gases also, very important, will be removed. Remember, those dissolved gases, they are not needed because some of them can enhance the corrosion, okay, of the steam turbine materials, especially the blades. Are we getting it? So here our concern is to ensure that all soluble salts are removed so that there will be no precipitation of such salt as the steam is getting cooled within the turbine. Okay, so that we now have those particles eroding our turbine blades, both stationary and rotating blades. Then two, we can apply protective coating, which is almost similar with the first solution, using the appropriate materials. Okay, applying protective coating so that protective coating that will be able to withstand or be able to prevent erosion of the blade. So those are some of the remedies that we can adopt. Therefore, corrosion, we can use corrosion resistant alloy, okay, on the in the production of the blade. Then secondly, the steam chemistry, we need to control the steam chemistry. Dissolved salts must be below the recommended parts per that is the recommended concentration. Okay, the concentration of silica also must be less than what is recommended for the operations of that steam turbine. Are we getting it? Then we need to remove oxygen. Okay, we need to remove oxygen. Remember, if you are adding oxygen scavengers, okay, the possibility of us having precipitate at the end of the day will be there. Okay, so we also need to add chemicals that will assist us so that such precipitates will not form within the boiler. Okay, which means that we need to maintain our blow down system and also the chemicals that present scale formation. Okay, we need to use all of these on the water treatment before it goes into the boiler. Then on fatigue, the same thing, we have to optimize the blade design. Then reduce vibration also. Okay, you know, vibration can result to repeated stress or stresses on the blade. And also controlling the chemistry of the steam will also assist us in this regard, because if the steam is bringing those soluble salts that will eventually form scale on the turbine blade, that will increase the vibration around the turbine blade, okay, the turbine, and that can eventually cause repeated stress. Remember, centrifugal force is always acting on the blade, and as you are increasing the weight of the blade, the force will also be increasing. Okay, so that will definitely cause increased vibration. Are we getting it? So controlling the water chemistry too, or the steam chemistry or steam quality, will also help us in this regard. Okay, then the operating temperature, we need to also control it. You remember, you know that once the temperature is fluctuating between two unwanted extreme, okay, so that thermal stress can actually cause fatigue, because the blade material will be expanding and contracting until a stage will come that the material will eventually fag out. Are we getting it? So we want to maintain and control the temperature, operating temperature of the steam turbine. We want to ensure that the steam is entering the turbine at the appropriate temperature. At the appropriate temperature. We also want to ensure that the cooling system of the steam turbine is effective to help us to maintain the normal operating temperature at every stages of the steam turbine. Okay. Then if there are cracks on the blade, they can always be repaired if they are minor, or else we need to replace that blade altogether. So to actually help us is for us to have a regular maintenance routine, okay, and a regular inspection routine. So we can actually look at the blade, especially on larger units, with infrared technology, okay, that will be installed in the steam turbine. So with that infrared technology, we'll look at how the temperature variations, okay, or the temperature is affecting the blade, and if we have cracks, it will also help us to see them before they cause catastrophic failure. Okay, so we can also, during shutdown, we can also do bore scope inspection, look at each and every of these blades to see that there are none that are cracked. If there are cracked blades, what we need to do is to change those blades. Okay, so on rupture, we need to replace those blades that are broken off. Then we need to carry out root cause analysis to determine what actually caused that problem, with a view to forestalling its occurrence in the future. Okay, so the rotor 2, there are some problems that are associated with the operations of the rotor. That is what we are going to be looking at in this section. So one of the problem is imbalance or unbalance. I will know what unbalance is. That is the center of mass of the rotor, as we discussed in our section on equipment condition monitoring, unbalance. So it is when the center of mass does not coincide with the center of gravity of that rotor. So that imbalance, okay, will appear as a throwing force. Are you getting it, on the rotor? So that will invariably cause serious one-time RPM vibration. Okay, so that is imbalance, and as the vibration is increasing, what will happen? It can cause the shutdown of the equipment on high vibration. Okay, and it will cause excessive wear of the bearing, cause the damage of all of these seals. Are we getting it? So unbalance is something that we do not want in the machine. So the next that we are going to be looking at is bending, okay, or bowing, BOW, shaft bow or bow. Okay, so the shaft, especially on larger steam turbine, can actually bend or bow. Are we getting it? So during operations, if there are temperature gradients on the rotor, of course that can cause some parts of the rotor to be expanding more than other parts. That will invariably or it definitely cause a bending of the rotor. So know the cause. That is, when there is temperature gradient, the rotor is not evenly heating, okay, or rather does not evenly does not absorb heat evenly, okay. So the tendency of it bending will be there. Okay, so that's bending. So and once the rotor is bent or bow, it also shows up as increased vibration. It can cause rubbing too of the rotor, okay, on the stator, damage to the bearings, and eventual damage, and also damage to the seal. Okay, so all of these are also unwanted condition. Then cracks can also happen in the rotor when there are excessive repeated stress on the rotor. Then also what we discussed earlier that affects the blades, turbine blade, that erosion and corrosion can also happen on the rotor, okay, especially on the areas where the steam is passing. The steam will come into contact with every part of the steam of the rotor, okay. So you will see that it could also be eroded. Corrosion can also happen. Are we getting it? So all of these are things that can affect the operations of the rotor. So what are the remedies? How can we remedy the situation, okay, when we have rotor problems? So let's look at unbalance. It is unbalance, like we said earlier, is something that will show up at one time RPM vibration, okay. That is vibration frequency information. Are we getting it? So if you are not familiar with it, you can check our training on vibration monitoring and analysis under equipment condition monitoring or under vibration analysis, okay, on our playlist. So the unbalance, once it has been observed that we have that high one time RPM and confirm that we have unbalance, the only remedy is to balance the rotor. That is what we have here, okay. So we will see where the mass unbalance is, and then we either add weight or remove weight. So all of these, they are meant to balance the rotor, okay. You screw it out or you add it to it. There are some that you have to wed to it, okay. So these are balancing weights, okay. So you either screw it out or you add weight to balance the rotor on both sides, okay. So that is what we are having here too. Are we getting it? So the only remedy is to balance. Once you have unbalance, is to balance the rotor. Then for bowing or bending, okay, remember bowing and bending too will also show up in one time RPM, but we don't need to allow the shaft to bend or bow, okay, during normal operations. So to help us to prevent such during startup, okay, and shut down when the equipment is coasting down, okay, after shut down, are we getting it? We actually need to keep the shaft rotating, that is the rotor rotating, okay, so that the rate at which it is cooling down will be even on all sides of the rotor. Are we getting it? Then during startup too, as you are administering steam, especially on those bigger steam turbine, as you are administering steam, okay, you have to keep rolling, turning the shaft so that the shaft will be heated evenly round the rotor, okay. So to help us achieve this, we have the turning gear. Are you seeing it? So during startup, when you are trying to heat up the equipment, raise the temperature of the equipment by administering some amount of steam, okay, controlled flow of steam into the steam turbine, okay, so that we will not get that thermal gradient. This turning jar will be set into operations depending on the kind of turbine and the manufacturer recommendation and even our own operating procedures, okay. The turning jar can rotate the shaft or the rotor of the steam turbine at between 3 to say about 30 rpm, revolution per minute. So it actually depends on the recommendation of the manufacturer. So to help us to do that is the turning gear. Okay, so during startup, as we are administering steam, the equipment has not actually come start turning. Okay, as we are administering steam to heat up the turbine, we will start the turning gear. Okay, to be turning the rotor at that very low speed to help us to evenly hit the rotor. Then during shutdown too, after shutdown, remember I want it to cool evenly. We don't want that temperature gradient to also develop to avoid this bowing or bending. Okay, the turning jar will be set into operations also. So it will be turning the shaft or the rotor of the steam turbine at that low speed, okay, until the equipment is fully cooled. Are we getting it? So that we do not have that temperature gradient along the shaft of the rotor, okay, along the rotor, so as to avoid bending. So proper use of this our turning jar will help us to avoid bending. Then during operations too, we need to also maintain the operating conditions, pressure and temperature of the steam that is entering the turbine at each and every stage of the turbine, and that is exiting also the turbine. We want to be sure that operating conditions are maintained. Are we getting it? So excessive fluctuations on these parameters too can result to this bowing or bending of the steam turbine. So we want to be very careful. Cracking also, we want to maintain normal operating conditions. Okay, use the appropriate material for the design of the steam turbine parts, the rotor, as in this case. So erosion and corrosion is something we can prevent by maintaining the quality of steam that is entering the steam turbine. Okay. Also, too, the they need to use the right material that will be able to resist corrosion and erosion that may be associated with the operation of that rotor on the steam turbine, as we said earlier. So other issues too that can result to problem are issues concerning the bearings. Remember, the bearing is meant to support the rotor, okay, during normal operation and to ease the rotation of the rotor around that within the casing of the steam turbine. Okay, so once they have issues, these two functions, it will not be able to perform them. Are we getting it? Thus reducing the efficiency of the turbine and may even result to other catastrophic events, okay, that may damage the turbine itself. So what are these issues? One, bearing wear. Remember, during normal operations, since we have sliding surface, okay, so like here now, we have this surface on the other is this rotor journal running on this bearing, okay. So there's every tendency that there must be wear of that bearing, the bearing itself, okay, because it is meant to wear um preferentially to this journal material. Are we getting it? So as it is wearing, that increases the clearance around the bearing, okay, and that will increase the vibration, reduce efficiency, and affect the operations of the turbine itself. Okay, so which is inevitable, is one issue that is associated with the bearing. So some of the common causes of wear is insufficient lubrication. Insufficient lubrication. If you have less than normal, okay, lubricant, okay, in the bearing, okay, it means that this bearing will not have enough lubricant to put around that bearing. Are we getting it? So that can cause the abnormal wear of the bearing. Then overheating too. Remember, it's a steam turbine. So if the seal is not functioning properly, it can cause overheating, stress the bearing, destroy the bearing, that will eventually affect the operations of. So overheating of the bearing can actually result to the bearing failure. Okay. So apart from maybe steam escaping to heat up the bearing, if it is not properly lubricated, that can cause overheating also. So this is the effect of overheating of the bearing, and that can result to excessive vibration, okay, and noise from the operations of the steam turbine. Then vibrations that can be as a result of that wear or overheating that will cause further wear, okay, of the bearing. All of those can result to increased vibrations. Are we getting it? So once it is worn, you will see that the vibration around the bearing housing will increase. Okay. So if the truss bearings also, if they are worn, you see an increase in axial vibration on that bearing end. Are we getting it? So the to and fro movement will increase because of the worn truss bearings. Okay. So that is another problem. So oil wire is another issue with the operations of the bearing. Remember that on each journal between the bearing and the rotor, okay, the rotor journal, it's expected between the bearing, okay, the bearing and the rotor journal, it's expected that some level of lubricant oil will be separating the shaft of the rotor from the bearing, okay, to ease that movement without wear, that rotational movement without wearing. Okay, so this is what we are saying. So you see that there is a thin film of oil that is always separating the shaft, okay, or the journal of the shaft, from the bearing itself. Are you getting it? So this thin film of oil can actually cause while, okay, maybe if we have excessive clearance or the weight of the rotor is not enough, you see that the tendency of this oil, as is pressurized, tendency of throwing this shaft of the rotor, okay, away from it, are you getting it, will increase, and that can cause whiling, excessive vibration, okay, and can cause that irregular rotating movement of the rotor. You know, during normal operation, it's expected that this there will be a little while anyway, but you expect that this rotor will be turning evenly, almost evenly. Are you get? But once there is while, you see that it will kind of be rocking around the bearing space, and that kind of movement will be enhanced when there is excessive clearance, and when the weight of the rotor, okay, is not enough. So this is a kind of Y movement, okay, and this kind of Y movement can cause the wearing of the bearing, excessive wearing of the bearing, that will eventually result to increased vibration. Are you getting it? So that's oil wire. So you can always see them at sub multiple frequencies. Okay, that is lower than the rotational speed, at frequencies lower than the rotational speed of that particular rotor. Okay, so you see them at sub multiple of the rotational speed. So once you notice significant peak at those sub multiples that were not there before, then you should be suspecting oil wire. Okay, so that's for oil wire. Then the seal also can fail. What can cause seal failure? Okay, you see that it can wear, as you can see on your screen, due to excessive friction. Are you getting it? It can wear due to excessive friction, okay, between the seal and the shaft of the rotor. So if that happens, that can increase wear and tear. Okay. Then if we have steam that is beyond, that is the temperature of the steam or the operating conditions, or rather you subject the seal to an operating condition that is higher than that for which it is designed, okay, that can cause the damage of the seal. So such damage of the seal will result to seal leakage that can damage other components of the steam turbine and thus reduce the efficiency of the steam turbine. So leakages too can happen. Remember, we have stationary blade and rotating blade. So the stationary blade, they are always designed such that the there are no escape route for the steam except through those nozzles, those stationary blade. Okay, so if there are leakages, it has other areas through which it is escaping. That would definitely reduce the efficiency. So in that case, it means that we have less steam impinging, assuming it is escaping maybe through, there is excessive wear around this area now. It is escaping through here. You see that we have less steam impinging on the rotor blade. Okay, so we have the steam turbine converting less, that is absorbing less and less energy from the steam into rotating mechanical energy. Okay, so invariably what that means is that the efficiency of the steam turbine will be affected. So once we see the efficiency going down like that, okay, during our normal routine maintenance, all the clearances are around all of these areas, all of them should be checked. Okay, all of the clearances around the library seals, okay, all of them should be checked. So here we have some of such. So all the shaft seal, they must be within that is the clearance of the shaft seal, as you can see, they must be within the tolerance limit. Okay, so if they are wearing out, that will mean that the efficiency of the steam turbine will reduce, because there will be leakage across all of these seals. Okay, so and leakages is something that we need to guide against. So all of these shaft seals, so if they are outside the tolerance limit, I mean the clearances, if they are outside the tolerance limit, then it is time for the seal change out. Okay, so all of these shaft seal, okay, so the clearances must be within tolerance so that the sealing system will be able to work perfectly. Okay, so all of these, they are the shaft seals, especially the clearances should be within tolerable limit. So all the tip seals and the interstage seals, the tip seals like all of these ones, okay, that is sealing the top of the rotating blade, between the top of the rotating blade and the stator itself, and also the interstage seal, so that there will not be unwanted leakages or passage of steam from one stage to another. Remember, our goal is to direct all the steam through this diaphragm or the nozzles, okay, of between, that is, of the steam turbine, so that it will be able to throttle it and direct it onto the rotating blades. Okay, so if there are leakages here, that will reduce the amount of steam that will be coming through this area, and that will thus reduce the amount of kinetic energy that will be available for conversion by the steam turbine, the rotor blades. Okay, so all of those seals, their clearances should be within tolerable limit. The tip seal, the interstage seal, all the shaft seals, all of them, they must be within tolerable, the clearances must be within tolerable limits. Okay, so next we are going to be looking at the problems associated with governors. Remember, we said earlier that the function of the governor is to control the speed of the steam turbine. So this is the governor on this single stage steam turbine. So this is the stop valve, and this is the steam inlet, and this is the discharge of the steam. Okay, so as you can see, this governor, his function is to regulate the amount of steam that is going into the steam turbine. So there could be problems associated with the operations of this governor that can affect the overall operations of the steam turbine. So what are some of the common problems that will be associated with the operations of the governor? One is the valve malfunction. The valve malfunction. Remember, earlier we described that the shaft of the turbine itself, the rotor, okay, by jar system is connected to the governor. So which means that the governor is looking at the speed of the steam turbine, okay, to regulate the operations of this valve. So since this is a valve, what it means is that all the problems associated with valves, okay, would also be associated with this governing system. Okay, so which means that this valve could stick. Are we getting it? So all these sparkings, there could be wear here that can cause the abnormal leakages of steam. Okay, then this valve could be stuck to a seat, which means that when you require it to lift, it will not be able to lift. And if that happens, it means that no steam will be administered into the turbine. Okay, or it could be stuck halfway. If it is stuck halfway, it means that a steady amount of steam will be going into the steam turbine, and the speed, you will not be able to, the governor will not be able to regulate the speed any longer, or it can stuck fully open. Once it is stuck fully open, it means that the maximum speed, okay, the maximum amount of steam will be administered into the steam turbine, and then the steam turbine will just be running at that maximum speed. Okay, so there could be wear and tear too. The the valve disc and the seat, okay, could wear out, and that will mean that it will not be sitting properly. When it is closed, it can still be passing. So if it is passing, it means that steam could also be administered into the steam turbine when the valve is closed. So all the problems associated with valves be uh, could also be associated with the governing system. Remember, the governor is to control the movement of that the valve stem. Okay, so there could be also complete damage. So if any of this happens, of course, it means that the governing system needs to be serviced if it is not controlling the way it should. So the governing system needs to be serviced. Okay. So remember we said the other time that the sensor, okay, that is tied to the governing system is looking at the speed of the rotor itself of the turbine. Okay. So if there is instability, that is, it could either be hunting, the speed will be going up and down. And what can result to this hunting? 40 valve too. So the fluctuating steam pressure too can also cause hunting, okay, or variation in the speed of that is the speed of the steam turbine, okay, because of variation in the control or instability of the governor itself. So those that are using hydraulic system, maybe if the hydraulic there is air ingress into the hydraulic system, okay, that can also cause maloperations of the governing system. So apart from that too, you see that if we have incorrect governor settings, if the governor settings is not properly made, it can lead to the fluctuations of the steam turbine, okay, or maloperations of the governor. So if the gain or droop settings they are not properly set, the governor control can overcorrect and lead to unnecessary oscillation of the governing system. If the governor too is too sensitive, okay, it will react excessively to minor speed variations. Small variation in speed, you will see that the governing system will change, thereby causing hunting and what have you. So mechanical problems associated with the governing system, like on the valves that we have discussed before, all of these can result to maloperation of the governing system. So if we are looking at those electronic governors, okay, malfunctioning of the electronic circuit, maybe sensors providing inaccurate speed or inaccurate load feedback, all of those can affect the governing system. Okay, variations in the steam supply, either changes in pressure of the steam supply, or even the quality of the steam turbine can also affect that the operations of the governor. Then load fluctuations too. Okay, so as the load is fluctuating, that can also affect the steam turbine. Remember, once the steam turbine is loaded, that can slow the engine down. Okay, and once the engine is slowed down, that will cause the governor to allow the injection of more steam into the turbine to increase the speed. Okay, conversely, if the load is reduced, the speed will go up and the governor will sense it. Are we getting it? And once the governor senses that, it will try to reduce the amount of steam that is injected into the steam turbine to reduce the speed. So if the load is fluctuating, okay, or is varying too often, that can also cause the haunting of the governor. Okay, so sensor errors, as we said earlier. Okay, so once the sensors are a kind of getting inaccurate speed readings, that will also affect the operations. If the speed that it is seen, okay, is different from the speed signal that is sending into the steam turbine or the governor, of course, that will affect the response of the governor. So all of these, they are common problems with the governor. So when we have this kind of problems, what we need to do is to service the governor. Okay, look for where the problem is coming from and then try to rectify that problem so that the governor will function properly again. So the last that we are going to be looking at, fourth condition, is with the that of the condenser. Okay, condenser issues of the condensing turbines. Remember, we said earlier that the condenser is a heat exchanger. Okay, so all the problems associated with heat exchangers, as you can see, will also be associated with the condenser. So here are some of the issues that could that can occur during the operation of the. So, but before we go into that, let us look at it briefly. So this is the area where the vacuum is established. This is connected to the exhaust of your steam turbine. So the steam comes into the condenser. It is condensed into liquid, which will now drop into the hot well. So cooling water goes into the tube of the heat exchanger. Okay, so invariably the condenser is a shell and tube heat exchanger, as you can see. Are we getting it? So whatever that affects the problems that are associated with heat exchangers, okay, shell and tube heat exchanger, is also associated with the condenser. So it is possible that we can have leakages on the tube. This will affect the efficiency, causing leaking of water, okay, into the condenser. Or rather, if the pressure of the steam is higher, cause leakage of steam into the condenser, which is rare anyway. So we also have the issue of fouling. So once the tubes are fouled, that will mean that the rate of exchange of heat between the steam and the cooling water will be affected, and that will affect the efficiency of the condenser. Okay, so that is the first one, fouling. And once there are fouling, what will happen is that the heat transfer efficiency will be affected. So the steam will not be condensed effectively, okay, into water, and that will affect the efficiency of the steam turbine itself. Okay, so this is the physical, how you see it physically. That is the heat exchanger, the condenser. Okay, so you can see the tube. So if all of these are fouled, maybe any of these tubes are blocked, you will see that that tube will not be able to exchange heat. No cooling water will be able to go through that tube, and thus the steam will not be able to exchange heat with that with whatever that is in that tube effectively. So there could be leakages, and once there are leakages, that can result to loss of vacuum. Okay, and once there are losses of vacuum, it will adversely affect the efficiency of the steam turbine. So the normal maintenance operations or strategy that you deploy on your heat exchangers, that is what you also do on the condensers. normal cleaning if you suspect that there are foulings. If there are leakages on the tube, you rehabilitate the tubes and recommission the condensers. So this is an overview of what we have been discussing. So here we have the steam turbine, and this is the exhaust of the steam turbine into the condenser. So this is where you establish your vacuum. Okay, you establish your vacuum here so that low pressure, okay, that vacuum will help to draw in more steam to be condensed in the condenser. So here you have the vacuum system, okay, that is ejector driven. You have ejectors here, as we explained earlier, that helps to establish the vacuum. You see that it is connected to the intake or input of the condenser, that is the exhaust of the steam turbine. So you have the vacuum breaker here, so that when the vacuum is put below a set limit, the breaker will open to break the vacuum, okay, to ensure that the vacuum does not go below that limit. So we have the condenser here, and then we have the cooling water pump, okay, into the condenser. So this is a brief overview of some of the problems that are associated with the operations of the steam turbine.